Welcome to the lecture on statistical models in simulation. So, this is the 6th lecture and we will start about the statistical models which are used in the simulation purposes. Going to the history or overview of why to use these statistical simulations or when to use, as we know, for a model builder in simulation, he sees the world in a probabilistic way rather than deterministic. So, as we have already discussed that when we talk about these type of systems, discrete event simulation systems, we have the probabilistic component. So, they see it in a probabilistic manner. So, stochastic models are there and they describe the variations. So, you have different kind of models, different stochastic models, and they will predict the variations, because things are not deterministic. Every time the probability is attached for any event to occur. So, that has to be predicted properly. So, that must be following certain kind of pattern. Now, these are basically presented well by certain kind of functions. So, approximate model can be developed by sampling the phenomenon of interest. As we discussed that if suppose we have to generate some numbers or we have to generate the inter-arrival time or service time, you know that will be basically predicted based on what has happened in the past. So, in the past the data are there which are basically recorded, which are stored. Based on that you will have a trend that okay, this is likely that this time will be there or this much will be the inter-arrival time for that particular customer in between that. So, this way the approximate model can be developed, and many a times guesses are used by the educated persons or the subject matter experts. So, they use the guess to get it. So, we will have the introduction to different kinds of terminologies while dealing with these discrete random variables or continuous random variables, probability distribution functions, density functions, cumulative distribution functions, all that. So, let us discuss one by one about them. So, coming to the random variable, as we know you have this is a variable which has randomness attached, and these random variables are of two types. When we study these modeling and simulation, you have a discrete random variable and we have a continuous random variable. Discrete random variable means it possesses many values. It will possess the values which are discrete, which are finite or countably infinite, which you can have a discrete identity. So, suppose any random variable x, capital X is there, it may have many values. So, it will have a range of the range or space. So, you have the Rx. So, if x is the random variable, Rx will be the range of space for the random variable. It will, so how much value it can attain. Suppose you are tossing a die, then there are 6 probable values, either it will be 1, 2, 3, 4, 5 or 6. So, this is the range is from 1 to 6. So, that is a random variable. When we toss a coin, what appears on the top face, that is basically an example. So, that is the outcome, it is a random variable, and the space is, so range of space that will be from 1 to 6. So, either we can get or 1 or 2 or 3 or 4 or 5 or 6. So, that will be, this is a kind of discrete random variable. Now, they are defined like this. So, Rx of a random variable x if it is discrete, that is if it is countable, finite in numbers, or countably infinite. So, in this case Rx will be going from one value to other, and normally the value which it attains, that is normally xi. So, xi is basically the values. So, I will be varying from 1 to whatever value it takes, and pxi so pxi is the probability that x takes xi. Now, as we know, we toss a coin. If we look at the probability in normal case, having any face coming to the top is 1 by 6. So, 1 by 6 is the probability value, and xi is either 1 or 2 or 3 or 4 or 5 or 6. So, now what we have certain properties about it. What we get in this case is that pxi will be greater than or equal to 0. In the case of discrete random variables, the probability of the individual outcomes, if we take the summation, so if we take the value of them, it has to be either 0 or it will be more than 0, and summation of pxi for all I, it has to be 1. This is the property of the discrete random variable, because you have the range, x will have a range, that is Rx, so it will be denoted by Rx. Then xi and pxi basically this is known as, for I equal to 1, 2 and all, this is called probability distribution of x. So, you will have on the x axis you have the outcome which is their xi, and on the y axis you have the probability of that particular outcome, and in that case that is, so xi pxi, it is known as the probability distribution of x, and pxi is called the probability mass function. So, x is the discrete random variable, and you have the possible values, that is xi. Now, let us take an example. An example is like, if in a die tossing experiment x is number of spots on up face. So, we suppose do a die tossing experiment, and if x is defined as the number of spots on the up face, in that case as we know the Rx will be, it vary from 1 to 3, 4, 5 and 6. So, this is a discrete random variable. Now, if the condition is given like this, that assume probability of a given phase getting landed is proportional to number of spots shown. So, if we see that the probability of any given phase which is getting landed is proportional to the number of spots shown, in that case you will have xi and pxi. So, you will have xi and you will have pxi. As we know, xi you have 6 results, 1, 2, 3, 4, 5 and 6. So, in that case the pxi values, if we say, if we take that they are equally likely, in that case it will be all 1 by 6, but then here the condition is that the probability is proportional to the number of spots which is being shown. So, it will be 1 by some quantity, it will be 2 by some certain quantity. So, in that case we have to sum them. So, it will be 1 by 21, 2 by 21, 3 by 21, 4 by 21, 5 by 21 and 6 by 21. So, what we see is in this condition, this is how the probability of appearing any phase varies, and you can have a graph. What we see is on this you will have xi and this will be pxi. So, pxi will vary from 1 by 21 to 2 by 21 to so. So, you will have outcome 1, 2, 3, 4, 5 and 6. So, what we can see is this will be 1 by 2, 3, 4, 5 and 6. This kind of distribution function we see this. So, this shows a distribution function and this is showing the probability value. So, this will be 1 by 21, this will be 2 by 21, like that. If we take the summation of pxi, if we sum them, it will be 1. If we see the pxi values, they are all either greater than or equal to 0. So, these are the conditions which are to be followed. So, this is a case of discrete random variable. Now, we will see the next kind of random variable, that is continuous random variable. When the random variable does not have the discrete values, it cannot be defined on a discrete point. Any outcome is not as a discrete value, in that case it is a continuous value. So, here you have to express this in terms of the intervals. When we get certain values or the probabilities, it has to be in certain interval or certain number of intervals. So, if Rx, that is range space of a random variable x is an interval or collection of intervals x is continuous random variable. So, what we see is the range space of a random variable, either it is an interval or a collection of intervals. In that case, it is known as the continuous random variables. You does not have that freedom to define at a particular point. In these cases, if you define at a particular point, the probability of that will be normally 0. Now, in this case, probability, so probability will be always expressed for a certain interval between one quantity and the other. So, probability that x lies in interval a b is, so probability will be x will be in between a and b, and it will be defined as fx dx a to b. So, in this case, normally this is nothing but if you have fx dx, so if you have a and b, it is nothing but this area. So, if you want to find the probability of this kind of random variable, it will basically the area under this curve is taken as unity, and in that case the value of this as a fraction, it will be the probability values. So, this kind of random variable is known as continuous random variable, and in this case fx is called probability density function of x. So, this fx is known as the probability density function of x. Now, its properties are fx will be greater than equal to 0 for all x in range space. If it is in the range space, then for that, for all x, the fx value will be more than or equal to 0. Then summation or integral into for the range space fx dx will be 1. So, if we have this range in this graph, if we take the area whole, it will be taken as the 1, and fx will be 0 if x is not in Rx. If x does not lie in the range, in that case fx value will be 0. So, in this case we can have the probability values calculation, like in many cases like in exponential distribution or so. Suppose we predict the life of certain instrument to predict the cracks or to predict anything, you may have certain kind of expressions. So, if you want to expect the life in between certain time, that you can calculate using these methods. Suppose for example, if fx is given as half e minus x by 2 for x greater than equal to 0 and 0 otherwise. So, such may be the problem, such kind of problem you may come across, where this is nothing but this is basically life of certain device which is used to detect the cracks in aircraft components. In that case, if you look at, you have x more than equal to 0, you have probability of this function value is half e raised minus x by 2. So, if you put x as 0, it will be 0.5. So, if you take the graph of this, it will be an exponential graph like this, it will go. So, this will be your fx. and in this case mean is about 2. So, you will have the values here. You take some values, you can have these values in this case. So, it is such. So, this kind of graph, this is a case of continuous random variables. Now, if you want to predict, if prediction is to be made for life between 2 to 3 years. Now, this is basically for the prediction of the life of this component, and if you want to predict for the life between 2 to 3 years, in that case what we see is we get the values 2 to 3 fx dx. Probability that the life of this product will be between 2 to 3 years will be fx dx a to b. So, you will have 2 to 3. So, you will have integral of half e raised to the power minus x by 2 dx and 2 to 3. So, if you compute this value, you will get as 0.145. So, here you will have 0.4, 0.8, 1.2, 1.6, 2, 2.4 like that. So, this way you can calculate the probability that, so such problems where the life expectancy will be required to be predicted, that any component will last for 2 to 3 years, its probability is about 14.5%. So, this is the example for the continuous random variables. Now, further we will define certain other parameters. Cumulative distribution function. Cumulative distribution function, it will be again a function which talks about the cumulative effect. So, if we take the discrete one and if you want to find the cumulative values at certain point, it will take the summation of all the values before that. So, it will be nothing but the addition of all the probabilities values for all the outcomes which is below that. Similar is the case in case of continuous random variables, where it will take from minus infinity to that value and then it will have the area under that curve. So, it is denoted by fx, capital Fx, and it is probability that random variable x measures values less than equal to x. So, fx will be probability when x is less than equal to x. So, that is what the cumulative distribution function is. If x is discrete, it will be, as we discussed, it will be summation of all the probability values. And if it is continuous, fx will be from minus infinity to x ft dt. So, this way the cumulative distribution function is defined. Now, in this case there are certain attributes of this cumulative distribution function. One is that it never decreases. So, because it is cumulative, so it will go on increasing. So, in this case f is a non-decreasing function, then limit x tending to infinity f x will be 1, because when x is tending towards infinity or towards the forward range of the space, in that case it is taking all the values into account. So, its value will be coming out to be 0, to be 1. So, it is take, that is why it is 1, but if we take the extreme left value, then it will be 0. So, similarly limit x tending to minus infinity f x, it will be 0. So, these are the traits of the cumulative distribution function. Now, there are other parameters, other terminologies while dealing with these statistical models. One of them is expectation, expected value or mean value, which will also be defined as mean value mu. Now, for a random variable, expected value of any random variable is defined as summation all I x I p x I. So, for a discrete random variable, you will have the expectation, that is summation of x I into p x I, or you will have integral of x f x dx minus infinity to plus infinity. This is for the continuous random variable. So, for all, for discrete x, and this is for continuous x. So, this is nothing but it talks about the mean of the values. Now, this is also known as the first moment. So, E x n, when n is greater than or equal to 1, is known as nth moment of x. So, this is the first moment of x. So, if we got E expected value of x square, it is nothing but the second moment of x, and this is calculated as summation for all I x I n p x I for discrete x. So, when we try to find the second moment of x, in that case it will be x I raised to power 2 into p x I, and that way if you find the summation, that will tell us E x 2, and for a continuous function, for continuous x, it will be minus infinity to plus infinity x n f x dx. So, this is for continuous x. So, these two discrete and continuous x, you define this mean or expected value from these formulas. So, from here you calculate the variance. They talk about the central value or the mean value. Now, many a times you have the data which talk about the variability or the variance or the spread from the mean, and that is basically expressed in terms of variance, and variance is defined as V equal to E of x minus Ex square. So, this way we find the variance. What we do is we take the difference from every individual value to the expected value and then take its square and the expected value of that. So, that is known as variance. It is also defined as E of x square minus E x of square. So, this way we compute the values of variance. Basically what happens, there may be positive or negative differences from the central value. So, what is the actually it takes the mode value or the modulus value. In fact, it does not take into account any kind of sign. So, if we take the normal average, the plus and minus difference may cancel. So, to nullify that we take the squares here and then get the difference and then we represent it in terms of variance. So, these things are used in case of these statistical models. So, we may have many kinds of problems which can be discussed while dealing with such cases. Now, let us try to see how we calculate the mean and variance for the loaded die tossing experiment. If we try to find the mean can be found by, so Ex, as we know Ex will be summation of xi p xi. So, xi was 1, 2, 3, 4, 5 and 6. So, 1 times 1 by 6, 2 times 2 by 6, 3 times 3 by 6, like that, 6 times, no, it will be 21. So, 21, 21, 21, and if you take that it will be coming as 4.33. Similarly, Ex square will come as 1 square 1 by 21 plus 2 square 2 by 21, that way 6 square 6 by 21, and that will be coming as 21. So, you can get it checked, and if you find the Vx variance, it will be E of x square minus Ex square. So, it will be 21 minus 4.33 square 2.22. So, this way variance can be found. Standard deviation is the another terminology which is used, which is the square root of this variance. So, you can find the square root of this, you can find the standard deviation. So, this way these are the terminologies which will be used in our frequent discussions and in our subsequent discussions. Thank you.